make an investment cast part, you need two molds. The first one is the wax mold, wax injection mold, which you see in the screen at the moment. The second one is the ceramic shell, which will be cracked after investment casting. This is the second mold. The ceramic shell will be cracked after each casting, but the wax injection mold will be used several times for producing a wax model. These wax models will be used in the next steps. Yes. We need a wax injection mold. This mold is mostly made up of an aluminum material. We call this as wax injection mold. And a wax injection machine or a wax injection press injects the liquid or the paste wax into this mold. After solidifying within this mold, the wax model is ready. This is the first step. We produce a wax replica of the investment cast part. At this stage, one important point is the shrinkage. The waxes or the all the liquids are shrinking and expanding during the changings between the liquid and solid. So this is valid for our wax. And we have to consider the wax shrinkage rate while designing the wax injection mold. After solidification and the shrinkage, we have to take the wax model with required dimensions. So at the design stage, we have to consider this point, and we have to discuss this detail with the wax supplier. Yes. After we finish and we manufacture our wax model, the next step is making the wax model tree. The next step is the pattern tree or wax model tree assembly. An apparatus which is similar to the soldering iron, we can call this as heated iron, is used to simply melt the wax model and the runner in order to make a proper connection. So we connect the models to a tree by simply sticking them to each other. Most of the foundries employ handy employees to construct these pattern trees because this is a very sensitive job. You have to be careful and you have to prevent the cracking of the wax models or the other sensitive points. So handy people are employed in order to do this job. So we can say that all pattern trees are handcrafted. Pattern trees should be carefully designed in order to let the inner surfaces to be coated properly within the next steps. Yes, this is important. The patentry design is another point. It has to be designed carefully after constructing the patentry. The latest shape of this tree should let the shelling operation. All the surfaces has to be coated properly. So at the stage of constructing the pattern tree, wax model tree, we have to be careful. The other point is the path of the liquid metal. The last shape of the model tree should be suitable to let the molten metal to fill the mold properly. Yes, when we make the casting at the end of the process, the design should let the metal to fill all the gaps. Yes. After making the pattern tree, the next step is the ceramic coating. Pattern trees are coated with a slurry. The slurry is prepared specially to stick the surface of the wax pattern tree. After dipping into the slurry, the pattern tree is immediately coated with refractory ceramic material. Ceramic sands, we can say. The sand sticks onto the wet surface and then it is left for drying. Yes, first of all, we dip our pattern tree into the slurry and make it completely wet. While it is completely wet, then we put it into a rainfall sander machine, and this machine makes a rainfall of the sand material. Then this sand material sticks onto the wet surface of the pattern tree. So the coating is made. But this is only the first coating. According to the design of the tree, the material, the part geometry, the coating stage will be repeated maybe 8 times. So in each coating, you have to wait for drying. This is a very time-consuming operation. On the other hand, at this stage, the person who makes the dipping and who makes the coating has to be a very handy man. So, because while making these operations, the worker will turn the pattern tree in different angles in order to guarantee that all the surfaces are wet and all the surfaces are coated with sand. That's why a very useful and very skillful person has to be employed at this stage. Yes. The ceramic material should be rigid enough to construct a ceramic cell, and it should let gas permeability. This is important for a successful casting. This step is repeated several times. This is one of the most time-consuming step of investment casting. The worker's hand sensitivity is one of the important points. The first layer is called primary coating at this stage. Yes, the first layer is called primary coating. The other layers are called backup coatings. The first coating is made with fine materials. Fine sands are used for primary coating. The wax surface is very fine, and we coat the wax surface with a very fine sand. Two fine surfaces meet each other. So this provides a smooth surface finish and surface quality at the end of the investment casting. The fine materials result with smooth surface quality in the finished cast part. On the other hand, the backup coatings are made with relatively coarse material. These coarse materials let the gas permeability at the stage of investment casting and cooling stability. And it helps the material to solidify properly after casting operation. Yes, this stage is repeated several times, maybe 6 times, maybe 7 or 8 times. We make the one coating and wait for a few hours to dry it. After drying, we make the coating again. Then wait for an additional 2 to 3 hours. Then once more. It is completed within maybe 6 times, 7 times. So in each coating, the thickness of the ceramic shell increases, and we reach an enough thickness of shell. After shelling operation, we make dewaxing. As you know, we make the shell around the wax pattern tree. And now we will melt the wax and make the inside of the ceramic shell empty. In order to make this, we mostly use a dewaxing autoclave. The autoclave applies the heat and pressure into the investment casting shells, and by the help of this heat and pressure, the wax is melted out and removed out. So at the end of this stage, we have an empty shell in our hands, and the holes in this shell is the suitable geometry of our investment cast parts. After completing the dewaxing operation, in order to remove some residue waxes and in order to get a robust ceramic shell, shells are sintered within a sintering oven. Yes, This is the sintering stage. We make this sintering operation around 1000 degrees. Yes, around 1000 degrees. We make this sintering operation. So the residue wax is removed from the inner holes of the ceramic shell, and the ceramic shell is heated and sintered, and its robustness is increased at the end of this stage. This step heats the shell and makes it ready to meet with molten metal. This step should be synchronized with the induction melting of the metal. Yes, this step should be synchronized with the next step, because while the sintered shell is very hot, we don't want to let it cool. And while it is hot, we have to pour the liquid metal into it. So this will help us to prevent the cracking of the shell because of the thermal shock. In order to prevent the thermal shock, we don't let the ceramic shell to be cooled. While it's hot, we will make the metal pouring. Yes, as you can see in the picture, while the shell is very hot, the liquid metal is poured into the shell. After completing the casting at this stage, we will leave the shell filled with the metal. We will leave it to cooling. Simply leave it for cooling. Yes. When the casting is cooled, we have to clean the casting and get the cast parts from the pattern tree. Now we have a pattern tree which is made up of metal instead of wax. So first of all, we want to clean the ceramic material, ceramic shell. We want to crack the ceramic shell after the cooling. So we use a vibrating hammer. There are some machines, vibrating machines, designed to clean these ceramics. Once the casting is cooled, a vibrating hammer is used to crack the shell and clean the casting. That's all. After this stage, we make general cleaning. We cut the single parts from the tree, metal pattern tree. We cut our single parts and make their grindings and cleanings. And in case we use several cut-off equipments at this stage and making some grinding. So these are the cleaning operations. These kind of cleaning operations are common for other kind of manufacturing methods. So the investment casting is using the same techniques to clean the metals. If needed, the shot blasting and surface finishing is made, and the inspection is also made. According to the needs, in order to get a clean surface, shot blasting is performed. Once the casting is finished, the parts are ready for inspection. Inspections may include the visual, dimensional, and material composition analysis. Yes, you know, or NDT testing, for example. NDT tests also may be performed. These kind of things are made after investment casting, and if everything is fine and the part is okay, then it is ready for dispatch to the customer. This is the general complete progress of investment casting. Yes. Now, I want to show you a video which I take from YouTube. They give all these steps in this video, which will be very useful at the moment for us to understand what's happening in the process.
Thank you for your interest in investment casting. If you're interested in learning more about the investment casting process. These precision castings are sometimes referred to as near-net sheet castings, since they can often be used with little or no subsequent finishing operations. The entire manufacturing process starts with wax patterns produced from injection dies. The defining characteristics of an investment casting, including its smooth surfaces, dimensional accuracy, and high degree of detail attainable, can be attributed to these dies. Each casting requires a wax pattern, which is a forcible replica of the casting to be produced. To produce the wax patterns, the dies are loaded into a wax press and filled by an injection voice with a special pattern wax in base form. The wax is released liquefies into the die. The die is opened and the wax pattern removed. This process is repeated for every part that is required. However, multiple cutting tools are used for each jobs. The beauty of internal control loss of an investment casting is one of its most versatile characteristics. This detail is formed using either simple holes in the tooling or by using soluble wax or ceramic coring techniques for more complex internal detail. For prototyping or very short runs, purchasing of production-oriented tooling is not always economical, so we offer the option of sufficient printed patterns produced using stereolithography from 3D CAD data. Once the wax patterns are produced, they must be assembled to a feed system called a screw. The screw is made from rectangular wax and designed not only to hold the wax patterns, but also engineered to form a sufficient pathway. Metal flows through the mold during casting to produce a solid, defect-free component during solidification. With the waxes now assembled to the screw, we have completed what is called a tree. To transfer the exact detail of the wax pattern to the casting, the trees are encased in a sealed ceramic shell mold. It is formed by robots dipping or investing the wax into a slurry, drying the tree and repeating. This builds up 3/8 to 1/2 inch of ceramic around the tree. It is this ceramic shell or mold which will receive the molten metal during casting. The first coat is called the primary. It forms the innermost surface of the mold. For that reason, it must be carefully applied in very controlled conditions to ensure the quality. Gradually, additional layers of increasingly coarser secondary ceramic layers are added, and the completed shell is formed. The next step is to remove the wax and screw. We do this by immersing the shell into either a steam autoclave or flash fire de-waxing furnace. The wax melts and runs out, and the shell is now complete and fully self-supporting. When the shells are scheduled to be poured, they are reheated to approximately 75 degrees to further condition and strengthen the ceramic shell. They are now able to withstand the thermal stress they must endure during the next stage. While the shells reheat, prepare and melt metal to be cast. When at the proper pouring temperature, the chemistry of the alloy is checked. This identification is directly engraved on each of the castings. The castings are now ready for final processing to the customer's requirements, including heat treatment, NDT testing, machining, or other value-added processes. The investment casting process is an economical manufacturing method that offers many benefits and advantages over competing processes. We hope this video has been informative and helpful, and thank you for your interest in Niagara Investment Castings.
Yes. We completed the introduction of the investment casting process. Now, until now, I talked about the general method. And now I want to speak about the technology adaptation of investment casting steps. Several steps are adapted to the technology according to the technological developments within time. So let's see what can be the technological applications of the investment casting. Yes. Coming to the technology adaptation of investment casting, the first thing is the 3D printing technology. 3D printed models replaces the injected wax models. This provides some advantages for investment casting process. Disadvantages may be elimination of the wax injection mold tooling. However, as 3D printing requires more time than wax injection method to manufacture a model. So this is mostly suitable for projects with small quantities. Or it is suitable for research purpose. Until completing the part development trials, we prefer 3D printers. Once the final shape is defined, then the wax injection mold is manufactured for serial production. Yes, I want to make some explanation more. For example, if you need some parts, but the quantity is very limited. For example, you need just 3 parts with investment casting. And you just for 3 parts, you don't want to make a wax injection mold. So the 3D printing technology is helping us at this stage. And instead of making wax injected models, we make 3D printed models, which replaces the injected wax model. These are also capable of being coated with ceramic material. So we use 3D printed parts as an option to injected wax model parts. This is the advantage of using the 3D technology. For example, if you are at the design stage of your part and there are a lot of design revisions in your project and you don't want to wait for the tooling of the wax injection mold, you directly construct your 3D printed models according to your design, and after every design revision you can make the revised part 3D printed. So this eliminates the long design processes, and if you want to implement your project fastly, you can use these kind of methods. This is for the project development side. Another benefit is for jewelry makers and dental laboratories. They use plenty of 3D printers for this purpose in order to develop the, for example, a jewelry maker, in order to develop the wax model or 3D printed model of the of a ring, for example, they have plenty of 3D printers in their shop floor, and they work these machines 2 shifts or maybe more than 16 hours or 24 hours a day. So they use these machines for serial production purposes. But as their parts are very small, this is of course very useful for them. But for industrial applications, we cannot adapt it 100% as the same as the jewelry business. Mostly SLA technology, the stereolithography technology, is common for the development of the investment casting models, but in some applications, SLS and FDM models, manufactured models, are also utilized for making investment casting models. As the technology is developing every day, the limitations are lowering day by day. Another application of 3D printing is the ceramic cores. Ceramic cores is a very hard and complex point of the investment casting, which makes the investment casting 1 step harder than the general investment casting. Ceramic cores itself is a very sensitive and very hard parts to develop. You have to, like developing the wax model and wax injection mold, you have to develop a ceramic injection mold for your ceramic core. If you have a project in your hand with ceramic core, you have to deal specially with this problem. So the 3D printing technology helps us here too. And this is very, very useful, I think. The ceramic cores are developed or 3D printed by 3D printing technologies. Yes. Making a proper ceramic core itself is already a critical process. Normally, the ceramic cores are separately manufactured. New 3D technologies allows foundries to make 3D printed ceramic cores. This technology accelerates the investment casting process and shortens the project implementation times in most cases. Yes. Instead of making a ceramic injection mold and investing into a ceramic injection machine, you may invest in a 3D printer which is capable of making these kind of cores and printing this kind of ceramic based materials. This is the one aspect of the technology, the 3D printing technology. After I complete, Dr. Ijaz will introduce us a lot of details, I hope, a lot of details on these points. Now, I want to continue with another aspect of the technology adaptation of investment casting. The application and the implementation of robot arms into the investment casting. On the model development stage, the first stage we can call, we mentioned about 3D printing technology. Now the next step is the development of the pattern tree and the pattern tree assembly. In some cases, the pattern tree is assembled by the robot arm. But as you can guess easily, this is not suitable for small quantities of parts. You have to program the robots and you have to manufacture the same part, 100,000s of the same part. So it will be meaningful to implement this kind of technology. Otherwise, if you have very small series of parts or very small quantities, this is not the logical way. But if we are speaking on the technological capability, yes, there is a technology which lets us to make the pattern assembly with the robot arm. One of the other benefit is the precision. If we make the job with a robot arm instead of a man arm, the sensitivity of the wax pattern trees are taken under guarantee. So every part will be the same. Every pattern tree will be the same. The angles, the distances of each patterns from each other, everything will be identical to each other. So this would be an advantage of implementing the robot. Yes. After the pattern tree, our next step was the development of the shell, the shelling operation. You know, we mentioned in the manual operation, first of all, we need to make the dipping operation. After dipping into the slurry, then we put the wet tree under the ceramic sand. So this operation is totally adaptable to the robotic operation and automation. The robot makes all the things instead of a manpower. So all the shells will be guaranteed that they are identical to each other. If a foundry has the investment capacity and has enough part quantities, foundries mostly choose to convert their technology into this. So the shell room or the shelling automation is the maybe one of the first technological adaptation of the investment casting process. Most of the foundries choose this operation to be made by robots because this is made several times. So if we control this process with a robot, it will be more sensitive than a human arm. The quality and the repeatability will be high. So this is the one of the most employed technologies within investment casting. The other point is the climatization of these shell rooms. We call this area where the shelling is made is shell room, and the temperature and the humidity should be under control for the effective drying of the shells. Yes. After shelling, you know, one of the most time consuming operation was the shelling, and you have to wait for the shell to be dry for the next coating. In each coating, you have to wait a few hours in order to accelerate the drying of the shells or of the coats. Some technologies are used. This technology is infrared technology, which helps the shell to fastly dry, but it has a big high investment cost. One of the biggest challenges of investment casting is the shell making times. It consumes too much time due to the shell drying times. Foundries aim to shorten the drying periods. Some infrared heating equipments decreases the time needed for the drying. So you can decrease the cycle time of your manufacturing process and increase the productivity or increase the daily numbers of the manufactured parts. The other technology adapted point is the vacuum technology. Also, this has a high cost, and these kind of castings are applicable generally for limited quantities. Vacuum technology allows us to pour some special alloys like titanium and superalloys. Casting of sensitive parts are made under the vacuum atmosphere in order to guarantee that the metal has no contact with atmospheric gases, and pores are avoided within the metal casting. Yes, some metals are very sensitive. Due to their sensitivity, it would be a choice to make the investment casting under the vacuum atmosphere, especially for defense, aviation, and aerospace, or some medical parts are manufactured under the vacuum atmosphere. This vacuum may be up to the 10⁻⁻⁶ bar, which is a very high vacuum, and so the gas contact of the liquid metal is prevented in the casting stage. This is a technology adaptation of investment casting. Another technological application, actually this is not just for investment casting. In a lot of different test applications, NDT testing applications, these technologies are utilized, but also investment casting is using and utilizing this technology for inspection. Visual and dimensional inspection is performed as always. Alloy composition test is made with spectrometer, and defects are determined by making X-ray testing. Even wax models are X-ray tested in some cases. So X-ray is a very useful technology. You can make the testing of your materials. At the end of the casting, you can make the inspection of your cast part, and also you can make the inspection of your wax model. Yes, this is another technological adaptation of the investment castings. So you can see the internal defects in your part. If there are some defects are found within the part, then it will not be sent to the customer, or it will not be used within the system, and it will be refused. Yes. Yes, I spent too much time of yours, and I'm very sorry for my poor English. I tried to speak carefully and clearly, and I hope everything is understood clearly. And thank you very much for listening my presentation and for your patience. If you have some questions, I will try to reply. Thank you very much. No problem, sir, according to English. Thank you. Thank you very much. Thank you. I hope everything was clear and understandable. I wanted to explain what our company does and what the investment casting process is, and what is the technology of the investment casting. I hope everyone get the points and have a good introduction of investment casting. Thank you very much. Thank you too. And now for the 3D technologies and applications and adaptation of the investment casting of these technologies, Dr. Ijaz will make us some presentation. I don't have enough information about the CPD points. I'm sorry for that. What are the effects of investment casting on industry? Which wax is suitable for which metal? What materials are used to make slurry? I will try to reply. What are the effects of investment casting on industry? in normal sand casting, you cannot get the precise parts. Mostly after the casting, you need the machining. But in investment casting, the situation is different. You make the casting into the hot ceramic shell, and the cooling is more stable, and the sensitivity and the preciseness of the investment casting is higher than the normal investment casting. Also, as you crack the shell at the end of the process, you don't have too much geometric limits. These are the advantages of the investment casting. So people choose to make investment casting of different materials. And I hope this is enough explanation. What materials, are used to make slurry? Silicate-based liquids are mixed with ceramic powders, and it has a formulation, but all foundries make their own customized formulation after getting some experience. And it is a special slurry. The liquid within this slurry and the ceramic powders within this slurry will be identical to the sands used in the shell, and can work and can be combined easily with the shelling material. Yes. How is slurry made? Yes, and inspected. The inspection of the slurry is made by making a viscosity meter, and they measure the viscosity of the liquid material, and that's the application. And what is slurry? What is sintering? What is SLA? Slurry is the liquid which we use for the shelling of the wax pattern tree. The sintering is the heating of the shell. When we heat the shell, the temperature of the shell increases, and the form of the sand particles change, and turns into a robust ceramic structure, which is very useful for investment casting. The SLA is the stereolithography, one of the most popular 3D printing technologies. SLA, SLS, FDM, these are the 3D printing technologies. Yes. Okay, Dr. Ijaz. And thank you very much for attending, and also Quality Solutions, and also Pakistan Engineering Council. They invited me to speak on this webinar. Thank you for providing this opportunity to speak in this webinar. Hello, this is AHMET EŞİYOK. I'm back again and coming to the investment casting. I think yes. Now we can take a few more questions. Any questions? How much slurry will be used per kilogram of metal? This is not calculated according to the kilogram of metal because according to the shape of the pattern tree, the consumed slurry will change. This is normally if a foundry makes this kind of calculation, it will be a very rough calculation according to their experience. So because within the metal we have the gates, sprue, the runners, which are not the parts, but they are the metals. So according to the metal or according to the cast part weight, it is not very a very useful way of calculating the consumption. What topic you taught here? Investment casting. Generally, the casting simulation softwares are used. Almost all casting softwares would be used for this purpose. Can you tell me about wax characterization? Which parameters are important for selecting wax for metals? There are different kind of waxes. Also, the waxes are different for jewelry, dental, industrial areas. But we are focusing on the industrial area. The waxes are generally made with filler materials, different chemicals, filler chemicals, or without filler materials. So they are characterized like this. And we have to take the advice of the wax manufacturer at this stage, because you will design the wax injection mold according to the advice of your wax manufacturer. Wax manufacturer will give you the shrinkage ratios. Wax manufacturer will give you his wax information, the melting point, and other details. So you have to combine your study according to your wax. Which wax? You have to select it. After you start with a wax, it is very hard to change it to another wax, because everything will be designed according to this situation. How much is the cost of installing an investment casting setup based on mass production? It's up to you. The technology which you select will affect the installation cost. What's the standard, most reliable and mostly used 3D printer around the world? I think Dr. Ijaz will give the exact answer for this. For making slurry, can silica sol be used as a binder with zircon sand only, or it can be used with quartz as well? Silica sol is one of the mostly preferred material for the liquid of the slurry. It's very widely used around the world, but instead of zircon sand, they mostly combined with the powders, not the sand, but coated with zircon sand at the first step of the coating. Why use printed patterns? Printed patterns are fast. For example, if you want to make an investment casting part injection, wax injection mold, if you want to manufacture it, it will maybe take a few days or a few weeks to make it ready. But if you put your model into the your design into the 3D printer, you will get the model within a few hours. You cannot manufacture a wax injection mold within a few hours, but you can manufacture your replica within a few hours by using 3D. This is one of the advantage. The other advantage is the project implementation process. For example, in automotive, in aviation, in other industries, when they design a part and when they want to implement the project, they make a lot of trial manufacturings, and sample parts. They manufacture sample parts. If you want to get the sample part, 3D technology will help you. You will never need to make a lot of toolings and all tool and mold revisions. So 3D printings are very helpful for decreasing the times of the project implementation. Small size of the pattern is for a low melting temperature wax. Yes, sir. Kaçan bir şey var mı? Why sintering is done during the process? In order to get a rigid structure which will be very robust during the investment casting, the pouring of the liquid metal, we make sintering. If we don't make sintering, the shell will be in the room temperature, and we will pour the hot metal, liquid metal, then it will simply crack and everything will be rubbish.
Hello.
Hello?
Hello. Now you can hear me?
I can hear you, Dr. Ijaz.
Oh, that's good. That's good. First of all, thank you very much. Very good presentation you have done. And
You're welcome.
here in my laptop there was an issue with the microphone. Now I fixed it. So I will take the opportunity to discuss about the few points related to the SLA technology, 3D printing, and
Yes.
the key points of SLA can use in investment casting. So investment casting process, we can just customize the design and part modeling and also the wax pattern making with the digital pattern making, which is tool free. So these all three steps, which is I highlighted here in the red box, so we can replace with the SLA pattern making. So, and then further you already explained the investment casting process. So I just explained what we can reduce the time and the efforts. So with the investment casting and with the 3D modeling and the 3D printing. So here we are saving with the digital pattern making, cost saving, time saving, and design freedom, which allow complex geometry. We can design whatever we can. And as you mentioned in your presentation that as based of the research purpose or the design processing and testing, we can utilize very quickly basis and time saving. We can make a 3D model and make after that utilize in the investment casting. So the second point is a rapid prototyping product where we can do the design verification and also the validations of the design. So, and after that, we will do the process in the investment costing. So these are the initial production costing, low volume production, as you mentioned in your presentation as well. So another way where we going through with the process of investment costing, there is a shell wax and the shell decentering. So the key point of SLA can use in investment costing. So it's also shell making, and then we can pouring. So this is also, we can say, the quick process of the investment costing. Also the factor, which is the quality, you can see in the picture, if we are using the SLA pattern. So these kind of surface problem or surface quality we can improve with the 3D printing, and we can make very good process. And maybe you can tell about this surface problem which we are facing the traditional way, and we can replace with the SLA technology. So also here the SLA owns the highest dimension accuracy, which is 0.1 mm we can get after the 3D printing. And among the other RP technology also, where is the FDM and SLA technologies, also we can make the 3D printer part. So SLA on the best surface quality compared with the other RP technologies, which is 1.17 micron after polishing. So we can say that the SLA technology in the investment costing is very good in terms of the quality and in terms of the time saving, and we can make a different model with the for the research purpose and for the modeling in different parts. So for that, we are representing here the Union Tech technology, and which they have very good printers for the SLA base, and the accuracy they are providing 0.1 mm. And the sizes, this is RS Pro 600, means 600 by 600 by 500. The volume of envelope which can produce any shape of part. And also they have 800 printer, and now they are make up to the 2 meter, around 2 meter envelope of the printer. So it's a big one, big printer which they are producing right now. So I have one video which is related to the investment costing process, and then myself and Ahmed also take some question. So please check how SLA technology can produce the investment costing process and investment costing part. So this method we can quickly make a 3D part, and definitely with different geometries and different shape of model we can make in the CAD softwares, and then we can make a 3D printer part, and we can use it in the investment casting. This is all about my side, and thank you very much all the participants, and thank you very much uh, engineering councils and Ahmed. So
Thank you.
if there is some questions, so we can take, we have 5 minutes, 4 minutes more. So we can answer these questions if you want to ask. Yes, Ahmed, if you want to add something related to 3D modeling.
Actually, I told all that I can remember, and thank you very much, and thanks for the Pakistan Engineering Council for, and thank you to your company, Quality Solutions, for organizing these kind of very effective webinars.
Yeah. So here one guy is asking about the does printer pattern reduce risk, right? This is actually the quick way and reduce the risk printer can affect in this. So definitely we can model any part. So if I'm just explain the reduce the risk. You know, when you are making a part in the CAD design, so at that stage you can verify and validations of the CAD, and also you can apply some forces over there, some simulations, and material fatigue you can check in the CAD software. So after that, when you verify and validations of your CAD design, then you can send to the printer, and printer will produce the part. So it means definitely it's reduce the risk of any projects.
There's a question: how will the CAD wax mold eventually be manufactured? The wax injection mold will be manufactured within a CNC machining center. The material of the mold will be aluminum in most cases, and simply be manufactured within a CNC machining center. After the part design, the mold will be designed according to the part geometry, and it will be manufactured in CNC. Yes. Yes, Dr. Ijas.
Yeah. So thank you very much, and all participants. And I hope this our efforts with the help of Ahmed. So I just appreciate your time and efforts to
You're
make a
welcome.
presentation for all the Pakistani engineers, and I hope that they got the good knowledge from us. Thank you very much. Thank you,
Thank you.
Engineering Council as well,
Thank
and
you.
bye bye.
Selamünaleyküm.